Okay, mini lesson plan on stoichiometry. Y'all did really well with this on the test, but basically, stoichiometry, you have to have a chemical equation. Y'all are always trying to use one, two, and three box to do conversions, but conversions are just a single dimensional analysis cross, whereas stoichiometry is where you're using that whole one box, two boxes, three boxes sort of affair. That doesn't look, I don't like that. But anyway, one, two, and three boxes. You have moles to moles, that's a single box. Moles to grams or grams to moles, that's two boxes. And grams to grams is three boxes. And you got two rules, diagonal units rule and 1 mole over or under grams rule. If you go by those two rules, you can't fail to do these. I mean, there's no way. The only thing I see you getting confused on is going backwards versus going forwards because you will have to work backwards because these are the only two rules we have. Um, so let's see what this looks like. Grams of O2 from grams of KClO3. You either have to balance an equation or have a balanced equation, but here it says using the balanced equation. So this is going to be a three-box affair, and I hate when you all try and cram in. Like the answer is only going to take that much room. Grams of O2. And so give yourself some room because the units rule doesn't really work if you can't tell what you're writing down or what units. And that's what I see more often than not. You cram something in and then you just don't even try and remember what it was to put it in there. Or you go, oh, yeah, that looks like a KClO3 or whatever. So remember, the units of my answer go in this top right box, grams of O2. The units of what we're given go in this upper left hand. So we're given 14 grams of KClO3. And then we got to start applying the rules to fill these boxes up with some units. Well, the first one I'm going to use is I'm going to go backwards here and I'm going to say the grams rule. The grams rule says that if I write grams down, that on the other side of that box, I have to write 1 mole of that substance, and that substance is O2. Every time you write grams anywhere on the other side of that box, you're writing 1 mole of that substance. Same over here. So by the diagonal rule, this has to be grams KClO3. And as soon as I write grams of KClO3 on the other side, I'm going to write 1 mole KClO3. That's just this rule and this rule, and that's it. And so now I've got a diagonal rule. So I'm going to go here, and I'm going to go moles of KClO3. Notice it's not 1 mole anymore because 1 mole rule only applies when I'm going to grams, but it's the units. The diagonal rule, the units have to be the same. So if I have moles of KClO3, it is moles of KClO3. And then I'm going to go backwards using the diagonal rule because it still applies. Whatever the units are here has to be the units back here. So this is moles of O2. And remember that every conversion is going to have a mole conversion right in the middle of it. It's going to have the moles of one substance over moles of the other substance. If you don't have this box in the center, this is going to be your single box when you're doing mole to mole. You're going to just have a mole ratio in the middle. When you go grams to mole, it's either going to be on the left or on the right, depending on whether you're starting with moles or ending with moles. But it is going to be in every conversion you do. So let's see where we get these numbers from. Moles of O2, this coefficient here tells me the number of moles of O2 that I'm using. So 3 moles of O2. Moles of KClO3, that 2 coefficient tells me that I'm using 2. Now I got to fill in grams, so I got to do 16. Each oxygen is 16 as 16 from the periodic table. 16 times 2 is 32 grams. And then we got to do a KClO3. So I've got 16 times 3. 16 times 3, which is 48, plus a chlorine. I'll say chlorine, which is 35.5 plus 35.5, and then a case, and then a potassium, which is 39.1 plus 39.1, 122.6. And now that you've got all the units and all the numbers, it's a math problem. It literally is 14, I don't know if you can see this, times 1 times 3 times 32. That's all the top. Enter. Divided by 122.6. Enter. Divided by 2. Enter. Divided by 1. Enter. 5.48 grams. 5.48 grams of O2 is what I'm going to use. So, first thing you have to know when you're tackling a problem is you got to know the stoichiometry. You got to know that using the balanced equation, you have to have a balanced equation. Anything else, they're just asking you to go from grams to moles of the same substance. Here I'm going from KClO3 to O2. Those are two different substances. That's when we start worrying about the boxes. If we're just going from grams of O2 to moles of O2, that doesn't require any of this. That's not stoichiometry, that is conversions. If I can cement one idea in your head, hopefully it's conversions and stoichiometry, because those are used in all the other things. You've noticed that you've used conversions when you do molecular empirical formulas. You use stoichiometry. So you're going to use these things more and more often. All right, let's get you started down the road to number 2 here. Number 2, how many moles of KClO3 are needed to make 3.5 moles of KCl? So it's a moles to moles. It is a 1 box. It is this guy. I have 3.5 moles of KCl. And I am going for moles of KClO3. So, knowing these two things, you know the diagonal rule. You know what the units here are. You know the rule for units of the top right box are units of my answer, and then it becomes a math problem. You know where those two coefficients come from. Now it's just a math problem. All right, finish this sheet up. Show me when you're done.